Hello everyone, this is the Promotory channel. Today we're going to take apart this gearbox. It's a Zanrad Fabric Friedrich Schaefer S690, a 6-speed gearbox with 6 physical gears, no splitters, no range multipliers, so it's a simple 6-speed gearbox. So, what's the reason? Over time, the gears started shifting worse, second, third and fourth, meaning there was grinding when shifting. Well, that means the cone rings are gradually wearing out, but the bus was still running. And then at one point we shifted into fourth gear, and that was it. If you look now, you can see that fourth gear is engaged, and it just won't disengage, meaning there's no way to shift it out. We connected the gear linkage, but the lever still stayed in the same position. Now I'll try to show you that it won't disengage. So, as you can see, it won't shift out of any gear. Maybe something happened with the shifting mechanism, maybe the sliders got stuck, or the safety lock came off. There's a safety lock there, or something else happened. Basically, it's either the shifting mechanism, or maybe the fork itself broke. I don't know yet, we'll take it apart and see. We can see there's some play on the shaft, like this. Well, that's pretty much always the case with these gearboxes. The bushings and the shaft are always a weak point. So what's the task here? First, we need to find out why fourth gear won't disengage by removing the cover. Basically, take a look, assess the situation, and check the condition of the gearbox to figure out what to do next. We'll repair this gearbox, or it'll be scrapped for parts. That's why we're taking it apart now, checking its condition, drawing some conclusions, and maybe we'll end up assembling this gearbox, or maybe a different one. We'll see as we go. So the first thing I do is drain the oil. Then I remove this bracket. Here we have the clutch boost, and you can see what kind of bracket it is. And here we have a thin leg. So if you break off this ear, you'll have a lot of trouble later. You won't be able to find a bracket like this anywhere. Well, we remove the sensor so we don't break or damage it. Then we take off the cover, install the gearbox, and remove the top lid to see what's interesting inside. Also, as you can see, the release bearing here has fallen apart. And the fork is in bad shape too, which is common for them because everything here has already been redone many times. Nothing is factory made anymore. The forks are homemade too. As you can see, there's no sealing, water gets in there, they rust all the time and they get stuck. The fork stops moving, revealing the release bearing was always pressing on the clutch basket, causing it to burn out. I'm starting to take apart the gearbox. First, I remove the bracket and the sensor. I've already shown the release bearing cover. Then, I set it down, drain the oil, and I'll be taking off the cover next. We'll see what's causing the problem, why the gear isn't disengaging. Let's go. So we check the oil and see that there's an emulsion, which means we have the traditional problem with these gearboxes again. The shaft got damaged, and through this bushing, water started getting in through the gear shift shaft. The oil mixes with the water and you get an emulsion, and accordingly all the resulting consequences follow from that. I took off the cover and let's look at the cover. When I removed it, the mechanism disengaged. So now it's in neutral here. There are no problems at the moment. So it wasn't fourth gear that was engaged, but sixth. As we can see, sixth gear is engaged. The fork moved in this direction. The synchronizer sleeve shifted toward the input shaft and I can't disengage it back. So something happened inside the synchronizer itself. Maybe the detents fell out. Maybe they got jammed. Or maybe some teeth broke. Basically, we need to take it apart and check. And here we can see that there's water in the oil. The driver just came by and told me that they changed this oil literally 20,000 kilometers ago. The oil that they drained was to it. There was a lot of water in it. Water came out before the oil. This oil is still fresh, with less than 20,000 kilometers of use, yet water is still present. Now we'll visually inspect all the gears and then remove the forks, the flange, the cover, the cup, take out the input shaft in general. We'll completely disassemble the gearbox. So, here we can see the reason why sixth gear won't disengage. I've already found it. If we take a look, the retainer has simply come out of the coupling, meaning the coupling has shifted too far forward. And the retainer just slipped into this gap. Basically, it shouldn't be like this. It seems there are major clearances here, which is what we're seeing. It popped out here unnaturally. Now the coupling won't move here at all, because it's just jammed there. So, that's it. We found the reason why the gear wouldn't disengage. Now we'll take everything apart. In any case, we need to check the cones and rings. I removed the front and rear covers, took out the main shaft, removed the flange, took off the rear cover and took out the forks. So now I set up the puller, because this bearing is tight, but not in the housing, it's tight on the shaft itself, on the secondary shaft. So I got this kind of puller. I already showed in my videos a homemade puller. The halves are clamped together and the bearing is removed with a screw. So I set up the puller and I'm removing the bearing. So, as we can see, the bearing came off very easily. That means either the bearing race itself is worn out, or maybe the shaft itself is already worn. We'll measure and check, but usually that's not the case. Usually it takes much more effort. Alright, now I can take out the secondary shaft as an assembly. And then I'll take out the intermediate shaft. I'm turning the 5th gear now. And we can hear some rattling in there. So I have a rough idea. There's a cup, a kind of thrust bushing, and apparently it broke apart. Those pieces are rolling around in there, yeah. That's why. And we can see scoring between the gears. So yeah, I've had a similar case on my channel before. There's even a similar video. I'm clamping the shaft in a vise and taking it apart. Looking at the primary shaft cone, we can see the wear here. Because of this we got more play, which allowed the retainer to pop out. And if we look at the cone and the ring, we can see that the ring has settled all the way down and spins freely. Naturally, the gear won't engage at all, because it doesn't slow down or match the speeds, the couplings and gears. So by looking at this cone, we can judge the condition of all the other cones and rings. Now I've looked at it and I pretty much understand everything. Why this happened, why the retainer fell out and 6th gear engaged, and why it wouldn't disengage, because the retainer got jammed. So the gear should be positioned like this, meaning this cone should have a little bit of play, but just a very small amount. Under this gear there's a cup with a thrust washer, apparently. This thrust washer broke apart. What happened when it did? The gears dropped down by a few millimeters, so the retainer was no longer making contact. Right here at this stop, you see there was some free space and it was able to pop out here. That's it. So all of this happened because the thrust washer under this gear broke apart. I'll say that all of this is a consequence, and the reason is the presence of water in the oil. Alright, now I'm removing one ring, the second ring, taking off the bearing, the hub, and then I'll keep disassembling the entire secondary shaft. So here we can see, here it is, this cap, and this is the washer that broke, just as I suspected. So it sits like this. It turns out there's this rim, a thrust washer for this gear and for this one. As we can see, it crumbled, it broke. Now I need to remove this cap, or rather this bushing. To remove it, I need to use this kind of puller. That means it's mounted on the shaft with a tight fit, so you need to apply some force to remove it. I've set up 3-job puller like this behind the 4th gear. Then I take a torch, heat up the bushing a bit, and try to pull it off with the puller. So I managed to get it off somehow, barely. It was so tight I thought the puller would break. It's hot. So I removed the 4th gear from the secondary shaft, and if we look under the gear, we can see scoring on the shaft itself, which means this shaft will have to be replaced. And accordingly on the gear itself, we can also see where the metal has welded to metal, so this gear will also need to be replaced. And on this side where the cup broke apart and the thrust washer fell apart, you can also see these kinds of buildups, like metal welded onto metal. Alright, moving on. I'm taking out the gear, removing the synchronizer hub for 3rd and 4th gear, and I've also taken off the 4th gear cone ring, and we can also see that the ring on the cone is spinning. It's seated all the way and still turns, so all the rings, all the cones need to be replaced. Alright, so the secondary shaft is disassembled. Let's see what needs to be replaced and what we can keep. Hold on, I'll sort things out a bit, and first I'll put the tools away. this needs to be replaced. This is for the secondary shaft. So that's all the cones, rings, the fourth gear of the secondary shaft, the bearings, all the needle bearings, and the cup. And one hub for the fifth and sixth gears, because it's worn out right here. It's worn out. It works with this cone, and you can see the wear here and here. So what else do we have? Oh, and the secondary shaft also needs to be replaced. As for the rest, the intermediate shaft stays as it is. No changes there. The teeth are all in good condition. And the gears for first, second, third, fifth, and reverse stay, as well as the hubs for first, second, third, and fourth. As for the bearings, I know yet. 8 mm postmortem curriculum check handish. Good email postmortem collaboration. I'm postmortem collaboration. Collaboration. We have to clean them. Collaboration. Maybe we won't restore this gearbox anymore because there are too many new parts needed. Let's not guess for now. We'll see how it turns out, and then I'll let you know. Here is the gearbox that I disassembled and need to work on. And here is another gearbox. So I've already disassembled one gearbox and taken some parts from it. We'll take parts from it, but we still don't have enough parts. So we'll have to disassemble a third gearbox, this one here. We decided to assemble it from what we have. So we'll disassemble one gearbox, then the second, then the third, basically until we get enough more or less decent parts. This is a MAN gearbox. It won't fit if we just install it as is, but some of the internal parts are interchangeable. So I'll take it apart now and see what we can use from it. So I won't film the whole process of disassembling the gearbox. I'll just record about a minute or a minute and a half of it in time-lapse mode. Alright, so I've disassembled the third gearbox. Now I have 3 disassembled gearboxes, 3 housings, basically. I've almost got a complete set for 1 gearbox. So from 3 disassembled ones, I've managed to put together 1 gearbox. So here I have the parts that need to be replaced. That's this row. And over here are the ones I'll be installing. So they're more or less in good condition. Some are in good shape, some are in satisfactory condition, let's put it that way. So the only thing I couldn't find in good condition is the gear. This one from the secondary shaft, the so-called mushroom or bushing, basically the thrust bushing and the hub. What about the 5th gear? Here's a set of gaskets and also the release bearing. It burned out here, so the release bearing will also be new. Next, my task is to clean everything. Now, I'll be washing all the internal parts, all these cones, rings, internal components that I took out. I'll also wash the housing and clean off the old gaskets. Now I'm doing some prep work, and here are some parts that didn't need to be replaced. I washed them right away, since the old ones will be installed. I picked out the parts that are more or less in good condition, washed them all in the washer. Then I got sick and went on sick leave, but now I'm back from sick leave. So we'll continue with the assembly. So it's possible that we'll have some adjustments now. So I haven't quite restored in my mind how everything is here yet. When everything was in progress, I kept it all in my head, but now there might be some adjustments. So now we'll look and try to remember where everything goes here. These are all my old parts, and I have some new ones too. I haven't checked them yet, that is, to do it. So now I need to remove all these gaskets, clean off the old sealant from all these covers. As you can see, there are still some left here and there. I just took them out of the wash and haven't cleaned them yet. So now I'm going to clean off all these old gaskets and sealant. From the housings, from the front and rear covers, and from the gear shift cover as well. Here I have an old gasket too. I need to remove it as well. I also washed the casing itself, and I will need to disassemble this shaft and check the bushings. Maybe to be continued. I cleaned the housing, cleaned the covers too, and put them aside for now. So my next task is to assemble the secondary shaft. Basically I checked and I have everything except for 1 gear, which should arrive in the next few days. But for now I'll assemble as much as I can up to that gear, so that all this stuff isn't just lying around on the table. And then I'll set the shaft aside and start working on removing this shaft, checking its condition, the condition of the bushings, and I'll also remove the gear shift shaft. So, starting the assembly of the secondary shaft, first I install the first and second gears. That means I first put in the needle bearing, then the gear, and then the hub. It's lying on the tile, heating up. Then the cone ring, then the clutch with the retainers. Basically, I'm assembling the first and second gears.
first and second gears are assembled. So I assembled the gears, installed the bearings, the synchronizer, and put it all together. This is the reverse gear engagement, the drive, and this is the reverse gear bushing. The bearing moves along it, the needle bearing for the reverse gear. So it gets heated and installed while hot. It cooled down and locked in place. Now I turn the shaft over and assemble the third and fourth gears. So, the first and second gears are assembled. Let's continue assembling. I found the fourth gear in good condition, so we won't wait for the other one. The new one will arrive, and maybe we'll keep it as a spare or return it. So, I've laid everything out like this in the order it all gets installed. Now I'm assembling the third and fourth gears. Alright, so the third and fourth gears are assembled. Now, I'm going to put the fifth gear thrust bushing on while it's hot. It's on the stove, already heated up. I'll install it while it's hot. The third and fourth gears are assembled. I installed the hot bushing and everything fit perfectly. So next I'm assembling the fifth gear, and basically all that's left is to install the reverse gear, assemble the needle bearing, and that's it. The secondary shaft will be ready. So I've also prepared everything in order. I laid it out first. I'll install the bearing, then the gear, then the new hub, the new cone, and everything else is old. I'm assembling everything. Alright, that's it. The secondary shaft is assembled. Here we also put on the primary shaft. I'll install it now so it's clearly visible. Well, basically everything can be installed. The shaft can be installed into the gearbox. Next I'll work on the cover. Disassemble the gear shifting mechanism. Check the condition of the shaft, the bushings, the oil seals, and so on. So first I'll remove this lever, then I'll take off this cover, unscrew the 4 bolts, and without disassembling everything else, I'll check the condition of the shaft. Well, most likely there will be a lot of wear there,
So I think I'll still have to take all of this apart, completely remove these keys, take off this cover, and fully take out the shaft. All right, we'll see as we go, but for now I'll start taking it apart. Right here, let's go. I opened the cover and we can see the condition of the shaft, so we can see that water got in here and everything is dirty. There are leaks, rust and water. Let's wipe the shaft and take a look. Yeah, so we can see that the shaft here is completely worn out. We'll have to take it apart and remove the shaft. Then we'll see what to do next. Probably weld it up and machine it for the people. I disassembled everything, removed the shaft and prepped it for the welder. I put a grinder disc over the splines and a bushing on the other side. This serves as a stopper marking where the welder should add material. That's it. Now I'll take the shaft to the welder and start working on the casing. I'll take out the fork, check the condition of the shaft and the condition of the bushings. Now we can see the gap here, about 3/1/6 of an inch. But everything is clogged with dirt there, so there isn't that much play, especially on the set-off casings. This is always the problem. First, the bushing gets worn out, and then dirt gets packed in there. There's a grace fitting here for lubricating these bushings. Now I'm unscrewing and removing this fork. Screwing it, there's one bolt underneath here, and then I'll knock out the shaft. Yeah, so we can see the condition of the shaft here. There's about 1/8 of an inch of wear. The diameter is smaller here at the top. Actually, it's better at the top on the opposite side. So it puts pressure and the shaft bends at the top on this side. And the wear is at the bottom on the opposite side. And accordingly, the condition of the bushings is about the same. So now I'm going to knock out the bushings, machine new bushings, weld up the shaft, and then machine the shaft. In general, I probably won't film this whole amount of work. I'll show it when the cover is completely ready, probably like that. we can see the runout is less than 1/10, but that's somewhere in the center of the shaft. So let's say it's a little bit bent, but for this shaft, that's acceptable. We leave everything as is and grind it down to 2500. Alright, the shaft is ready. This is how it turned out. Basically, it's fine. I went over the whole thing with fine sandpaper and polished it a bit. The corrosion here is already deep, but it doesn't matter much for us. The shaft has been repaired several times, and you can see traces of old welding. It'll still work for a while. Let's put it this way. The shaft is ready, so I'm starting to assemble the shifting mechanism. I take this cover and install a new bushing and new oil seals into it. This is my needle bearing. It goes right into the cover. It's installed right here. I knocked out the old one. Here's what the old bearing looks like. You can see the rollers have already fallen out. And here's what the new one looks like. As you can see, everything is great. The oil seals and the bushing hold the shaft under its own weight. It doesn't drop down, but at the same time it moves freely. Alright, next I'm installing the bearing and assembling everything. I've already laid everything out. That's it, the bearing is in place. And now the shaft goes in like this.
I'm starting the assembly.
So we assemble everything like this. One barrel that I installed here goes onto this retainer, and the 3 barrels that I installed directly move the forks and shift the gears. Alright, the shaft is installed. Now I just need to hammer in this key like this, and that's basically it. Next, I need to install the springs and finish a few small tasks. The main work is done, so nothing gets mixed up. That's why I make marks on purpose, because you can't keep all this in your head. It's easier with marks. So this is a continuation. I've installed the key, checked everything, and all forks move. I can keep assembling. Now I'm installing this retainer with the spring. And then I'll put on the side covers and so on. Alright, I've installed all the springs. That spring works in that direction. This spring pushes the shaft this way, bringing it to neutral, so it ends up in the neutral position. That's it. Now I'm cleaning off the old gasket and installing the cover. Alright, next I'll be installing this upper cover. This is where we replace the bushing and the oil seals. I applied sealant on both sides and cleaned the threads. And now I also want to mention why we have this kind of wear here. This bushing, it turns out, doesn't get lubricated at all because all the oil is here in this part of the gearbox. The gearbox sits like this, lying on its side. So the oil level is here. And as a result, the oil just doesn't reach this spot at all, not in any way. There's no forced lubrication here, and naturally with gravity alone the oil just doesn't get here. That's why we have this problem in this spot. You could say the bushing is working without lubrication. Now I want to grease the shaft itself and also fill the space between the bushing and the oil seal with this grease. So for a while, of course, it will hold up as much as possible and it will extend the service life of this bushing. So this way I pack the grease in there. The gap is quite decent, about a whole centimeter, and in terms of volume, several cubic centimeters of grease definitely went in there. I think this will be our best option, the best solution for this assembly. As you can see, I tightened it a bit here. Now I still need to install this bracket that holds the rod. I tightened it a bit like this to check how the shaft moves, and as you can see, the shaft moves perfectly. It's smooth, with no binding or misalignment, and everything is great. As you can see, there's no play at all. Alright, now I'm going to install the rod, tighten it, and the cover will be ready. Here, I removed it, marked my position, and installed it back according to my mark. I'm installing it and checking, as you can see here, the reluctance. In the end, it turns out that this rod is not the original one. So this is already in place. We'll figure out who messed things up here, who did this nonsense. And because of this, you can see even this spot here, it got bent.
And if anyone saw this part of the shaft, it's also a bit bent. We'll figure this out as we go. For now, I've installed and tightened it, though the rod probably isn't original. We'll handle it here. I put in a long bolt because the thread was stripped, tightened it all the way, and put on a nut. If the thread is stripped, but some remains in the body, about half or a third, this is a good option. Tighten it, everything holds perfectly, and my cover is ready. Everything's great, it worked out, everything's fine. So I'm putting the cover aside, and next I'll work on the shaft for the clutch release bearing focus. So I also gave it to the welder like this, and the welder built it up like this, so everything's great. Here where the key is, I covered it with a bushing to keep out welding splatter or anything else. Then I go to the lathe, machine it, then to the cylindrical grinder, and the shaft will be ready. So my shaft is ready. See, I've polished it. Here's the size. I want to show it. Yet I made it a bit smaller. See, right now we see the size is 39.96. Sound of grinding. We also see the size is 39.96. I made it just a bit undersized. So this part here has a diameter of 39.9. Here I made it 39.96. But I'll make the bushings around 40, 45 or 41. Like this, so there's a little bit of play, a gap, because if you make the shaft too tight it gets stuck. I've had that happen before. The shaft is ready. I'm taking it out of the lathe and I'll continue working. The bushings. So here's the shaft and here are the old bushings. And here's a piece of bronze that I'll use to make new bushings.
Here are the bushings we ended up with. I drilled a hole there, made a small groove for lubrication with a cutter. Now I'm hammering in the bushings and installing the shaft. So I hammered in the bushings. The shaft goes in, but it's tight. Even though I left a whole tenth of a millimeter of clearance, the hammer still made them fit into place. Maybe there's a slight misalignment somewhere. Maybe they got squeezed a bit and became a smaller diameter. So I had to take a reamer and go through with a 40 reamer. I'll go halfway since I don't have enough length and we'll need to do it from both sides. So I only went through one bushing. We can see that it was the only thing holding it. I didn't touch anything else, so the shaft fits in fine now. Now I'll blow everything out and assemble it. Grease fittings are here for lubrication. Check the channels. Air passes through, so grease will as well. Grease it often to keep it working properly. So now I'm grazing it, putting in the keys and assembling it. Well, I assembled everything, put in the fork, and now it moves like this. It holds the sealing rings on this side, under the washer, and on this side as well. That's why it feels a bit tight, but actually it's easy. So everything is great. The cover is ready. Next, I'll start assembling the gearbox. So I took the secondary shaft out of the vise. I'm not putting it on the table because if I do the clutch might come off the retainers. Now I need to put on the reverse gear. I prepared the reverse gear and installed the bearing. Here there are only loose rollers. I greased them and now I'm installing the gear onto the secondary shaft. Now my secondary shaft is completely ready for installation. First I will install the intermediate shaft. I installed the intermediate shaft, heated the bearing, and pressed it on. I installed the retainer here so that when I put the gearbox in, the race doesn't accidentally fall out. Later, when I install the cover, I'll remove it. Now I'm going to install the secondary shaft. Next, I'll install the rear bearing race of the secondary shaft. I place the race on the tile, heat the bearing, and press it in. Alright, the rear bearing is in place. Now I'm installing the primary shaft. All the shafts are installed. Now I'll be closing the cup and the rear cover. First, I'm closing the rear cover. I'm installing the rear cover. So what I did was wash and clean it, remove the old gasket, replace it and install new oil seals. The oil seals are new. So I'm leaving the old washers because I didn't do anything with the bearing, just replaced it. I'm leaving the old washers and taking a new gasket. Alright, we're done here. The lights went out. So I've already applied the sealant. I need to get this done. I need to finish filming this, so I'm taking a new gasket. I've applied sealant around the perimeter, installing the speedometer drive, got the bolts ready, and installing the rear cover. Let's go. So I've tightened the cover, immediately installing the flange, applying sealant to the splines. Sometimes oil leaks through them. I always apply it just in case, and a drop of oil onto the seal, installing everything. Next, I'm installing the front cover. I applied sealant to the so-called cup. The new seal, kept the old washer, took the gasket and installed it. Well, that's it. The gearbox is assembled. I've installed everything and I'm now putting in the forks. They're cleaned and ready. So once I install them, I'll close the cover. I'm securing all the forks except for the reverse gear. For the reverse gear, we need to have free movement to install the top cover. So I've installed and tightened the shift forks. Next, I'll be pouring in the oil. The oil is poured through this plug and there's a check hole. The oil will be like this. We have 100 taki. Basically, lately we've only been using this one. GL4 is used for synchronized gearboxes. So I'm pouring in, I think 13 or 11, I already forgot. Anyway, we pour until it reaches the plug. Okay, all the oil has been drained. We can see by the plug. It's even a couple of millimeters higher, but that's a minor detail. That's it. Now I'm going to close the cover. I'll check the gear shifting without the cover first, and then I'll close the cover. Next, I'm installing the cover. I've applied sealant. So the cover is installed and tightened, everything is good. I'm laying the gearbox on its side in its working position, and I'll be installing the casing. Alright, the casing is installed and tightened. Next, I'll be installing the release bearing. The release bearing will be new, since the old one fell apart. I welded this plate here because the fork was jammed and it was constantly in a pressed state. I welded the plate, and that's it. So now I'll grease it inside with regular lubricant and install the release bearing.
So I installed the release bearing like this. I fastened one clip here. The lower one, as usual, falls out. Basically, the function of this clip is to hold the release bearing during the installation of the gearbox. So it's not really needed during operation when the gearbox is being installed, just in case the release bearing doesn't fall out. That's its only function. That's it. Everything works perfectly now. We have a restored shaft, new bushings, lubrication, and a new release bearing. Everything's great. I tightened the fitting, but the hose isn't installed yet. The drivers will install the hose for lubricating the release bearing later, themselves right here inside. Well, basically I packed a lot of grease in there, so it'll be enough for a while. There's a fitting for lubricating the release bearing. It moves along the sleeve, not where the ball bearings are, but exactly where it slides along the sleeve. That's how it works, that's it.
My gearbox is already assembled. There won't be any painting since there's no time. There's a lot of work. So my gearbox is ready. I'll also say that any activity on the channel is welcome. Comments, likes, sharing the video, hitting the bell. Basically, any activity is appreciated. The more we appreciate it, YouTube algorithms promote the video. That's all. Thank you to everyone who hears me. Thank you all. I'm going to finish this video. That's how the video turned out. Thank you all for watching. Good luck to everyone. Goodbye.